So the main objective of this demonstration is to show everybody the SoftStarters general operation, but also discuss some of the main topical points of how the SoftStarter actually compares to other switching methods for turning a motor on and off. So as you well know, there's many different ways in which you can switch a motor on and off. So soft starters, direct online starters, star delta starters, and there's also VSDs, but there's also many more different variants. But these are certainly some of the more common ones in which you would switch a motor on and off. Now, one of the key elements of a DOL, a star delta starter, and a soft starter are these can only be used for fixed speed applications. So if you was looking at variable speed, the best option to choose would be a variable speed drive. But one of the main issues or things that we might consider when we're switching a motor on is the impact that the starting current has on the motor itself. So say for example a direct online starter, that's a physical switch. So as soon as you press the on button, 3 physical contacts inside that contactor will turn the motor on. So there's a certain amount of energy, a certain amount of current, and a certain amount of torque which it would take to get that motor to turn on. Now, if it's just a physical switch, it consumes a huge amount of current on the startup, but also a huge amount of torque. Now, that'll have a detrimental impact on the motor itself. So the idea is what we want to try and do in certain applications, especially the audious ones, say for example a crusher or a milling machine, we want to use different methods where it has less of an implication on the motor itself to give it a longer lifespan. So we're trying to reduce in effect the current so it effectively makes your motor last for longer. So a DOL typically consumes 8 times the rated current on a startup. Very similar to a DOL, you have a star delta starter combination, and I say it's very similar because it's still a physical switch, except it's 3 physical switches combined, which effectively share the load, and that can reduce the current by up to 3 times. So these are typically used for heavy duty startup motors. For example, as I mentioned earlier, star delta starters could perhaps you could use them for lathes, milling machines, for example, saw blades, bandsaws, applications of that nature. And they can typically draw 3 times the rated current. So that is okay, that is a reasonable amount of starting current, but this is also classed as what is an older form of technology. Now, the second best option that you have is to use a soft starter, and that can achieve up to 2 times the rated current on the startup. And then firstly, the most efficient way of starting up a motor would be a VSD, which brings the motor in at a load level. So say for example, if you have a 12 amp motor, it will not exceed that 12 amps in certain applications. But how does the soft starter achieve this 2 times the rated current? We'll just have a little look at that. So as you can see on this right hand side, you've got a soft starter, and there's 2 pots on the front of the unit. One's for the starting voltage, and then the other one's for the ramp up voltage, or the ramp up time, should I say. Now, this graphical representation displays the general operation. So this axis here shows the voltage, and this axis here shows the time. So we have a starting voltage, which is set here, and then there is a ramp up time, which is increased here, as you can see on this diagonal line. And the idea here, I'll give you an example. So you have the starting voltage pot that can be set from anywhere from 0 to 100%. If you set it at say 50% and you were in the UK, you typically use 400 volts. So if you set it at 50%, that starting voltage would initiate at 200 volts. With that 200 volts, you could set a ramp up time of 10 seconds, and from that 200 volts, it would take 10 seconds to reach the 400 volts. So it's effectively a gradual increase in voltage up to the full line voltage, and that's exactly how it achieves the 2 times the rated current. So one of the main factors when you're looking at specifying a motor and optimizing your motor's control, it's certainly having one eye on how much current the motor's consuming on the startup, which will have an impact on the lifespan of your motor. This next slide just gives you an idea of the advantages of using a soft starter. So on this right hand side, you've got the configuration which is inbuilt into a soft starter. So there's 2 different types of soft starter. There's a 3-phase control device which is shown here. So on each of the phases you'd have one of these configurations. But there's also a 2-phase control device. On the middle phase, it would just be straight through rather than having the anti-parallel thyristors and a built-in bypass. It would just be a straight through contact. Now, the way that this works is during the startup, once an in signal has been received, what happens is the voltage and the current passes through the anti-parallel resistors. And the reason behind that is because if you place the voltage and current on a mechanical contact, it would effectively produce wear and tear on that mechanical contact. But if you're using anti-parallel thyristors, what happens is it takes a lot of that burden and a lot of the strain off that mechanical contact. Once the device has reached the full operational speed and the operational voltage, what happens is this mechanical bypass closes, and the idea behind that is because these anti-parallel thyristors switch so quickly, they dissipate a lot of power and in turn a lot of heat. So there's a lot of losses in that. And the idea is if you switch that out, it stops it eradicates that problem of power loss and heat loss. Similarly, when you're turning the motor off, this bypass contact unlatches and the anti-parallel resistors then again gradually bring the motor down to a standstill. And the idea is that reduces the implication of wear and tear on the mechanical contact, but also reduces the implications of arcing on that mechanical contact as well. So how does that compare to, say, for example, a direct online starter or a star delta starter? So if you're using a soft starter, you can achieve up to 30 million operations, whereas with a contactor, you can only achieve 3 million operations. So when you look at a DOL or a star delta starter, roughly 3 million operations before you have to change the device out. But if you're using a soft starter, you can achieve up to 30 million operations, which means it lasts for a lot longer than a physical contactor. So that's where the benefit is of choosing a soft starter over a mechanical switch. So where does the benefit lie when you're comparing against, say, for example, a variable speed drive? Well, the advantage is in if you're using a motor or switching a motor at full speed at its 100% of its operational capacity, then the soft starter is the most efficient way of switching your motor, because there's no energy savings there to be made. So all you're doing effectively is you're using a motor at full speed, and effectively you don't have that mechanical bypass contact in there, so you're using thyristors constantly, which means there's a lot of power and a lot of heat loss. So if you're using a motor at fixed speed at 100% of its operational capacity, then a soft starter would be the correct device to select. If you're looking at making an energy saving, you can reduce the speed of the motor by selecting a drive and make energy savings from that respect. So another question which gets commonly asked is when you would use a soft starter and what are the main advantages of using one. So here are 3 questions of when to use a soft starter. So if it's a fixed speed application, use a soft starter. If there's no requirement for precise starting and stopping, you would definitely use a soft starter. And also, if there's no requirement for full torque at 0 speed. So, typical conventional control gear has various different implications on the power network. We always suggest to use various different methods of switching motors on and off. For example, if you was using direct online starters throughout a factory and you were switching them on regularly, that would have implications on your power network. It could potentially cause lights to flicker, relays and contactors to drop out, and computer systems to crash. And that's because, as we discussed earlier, that if a DOL switch is on and off, that effectively switches on and off at 9 times the rated current. So if you have multiple devices switching 9 times the rate of current, that will have an effect on various different components on the network. So what are the advantages of using a soft starter? So the advantage of using a soft starter is you get a smooth starting and a smooth stopping procedure through the gradual voltage ramp up and the gradual voltage ramp down. Further to that, in turn, with a reduced current, you also get a reduced torque because they're proportional, and also an increased life expectancy of the motor. So hopefully you found the demonstration and explanation useful. If anybody has any questions, please feel free to give me a call or even contact me through my YouTube channel. Thanks very much for watching.